Welcome to a slow, beginner-friendly lesson on the Capstone mini project in Python, made for absolute beginners. Capstone time. Today is the capstone. You build one small, real tool that combines every skill you learned in this chapter. The tool is a command line program that fetches data from a public API, writes it to a file, and prints a clean summary. To build it, you use modules, error handling, logging, configuration, secrets, tests, and packaging. Nothing new is invented. Every piece is something you already met. The lesson is in how they fit together. When the tool runs, you will feel the whole chapter click into place. Everything clicks. Your project has this shape. A folder called weather_fetch holds everything. The .env file lives at the root, next to pyproject.toml and .gitignore. The real Python code lives under src/weather_fetch, split across small files, config, logger, fetcher, CLI, and a _main file so the package can be run as a module. Tests live in their own folder. Notice how each concern has its own file. That is the central habit of professional Python. Many small files. Create the project with UV space in it. Add two libraries, requests for calling the API, and python-.tn for loading the .env file. Add pytest as a dev dependency so you can write tests. Then create the source and tests folders with mkdir-p. UV records every dependency in pyproject.toml, so anyone who clones your project can reproduce the exact same setup with a single command. Two libraries today. First, put your API key in the .env file at the project root. Then run the tool with UV space run space python space -m space weather_fetch, passing --city and a city name. Once you package it, you can also call the installed command directly, weather-fetch. To run the tests, UV space run space pytest. 4 commands cover the whole project: configure, run as module, run as command, and test. 4 commands total. Look at the tools you have collected. Today you put them all into one small real tool. The collected tools. Here is what we build. A command line tool that takes a city name, asks a weather API for the current conditions, writes the raw response to a JSON file on disk, and prints a short summary like the temperature and description. Small enough to fit in your head, real enough to use every pattern from this chapter. By the end, you have a tool you can hand to a friend. The weather API is just an example. Swap it for any API and the structure stays the same. Small and real. Look at how every skill from this chapter appears. The work is split across modules. Errors are caught and reported with clear messages. Logging records every important step. Configuration and secrets live in the .env file, never in the code. Tests confirm the parsing logic works without calling the real API, and packaging turns the project into a real command you can run from anywhere. 6 skills, 1 small tool. That is the capstone. 6 skills, 1 tool. Each file has exactly one job. Config.py loads the .env file and exposes settings like the API key. Logger.py configures the logger once, so every other module can import it. Fetcher.py knows only about calling the API and parsing the response. CLI.py parses arguments and prints output. The _main file is the entry point that lets you run the whole package with python-m. Splitting concerns this way keeps each file small and easy to test. 1 concern per file. Modules, errors, logging, and tests meet in one project. The pieces finally talk to each other. Pieces meeting. Config.py is the single source of truth for settings. It loads the .env file, reads the API key from the environment, defines the base URL of the API, and creates a data folder for output files. If the API key is missing, it raises a clear error immediately. Every other module imports what it needs from config. The rest of the code never touches os.environ directly. That keeps the project easy to change. One file holds every configurable value. Settings in one place. Logger.py configures one logger and shares it across the project. The function get_logger takes a name and returns a configured logger. The first time it is called, it adds a stream handler that writes to the terminal, sets a friendly format with timestamp and level, and sets the level to info. Subsequent calls reuse the same logger. Any module that wants to log just calls get_logger with its own name. That is how a project gets consistent logging without repeating setup. One shared logger. Fetcher.py does one thing: call the API and return the parsed body. It imports config for the API key and base URL, and imports the logger. Inside the function, it logs an info message, calls requests.get with the city and the key as parameters, sets a 10-second timeout so the program never hangs forever, calls raise underscore for underscore status to turn an error response into an exception, and returns the JSON body as a dictionary. 10 lines, 1 responsibility. 10 lines, 1 job. At the end, you have a tool you can run from the terminal. Small, real, and entirely yours. It runs. Errors should never crash the tool silently. Here, the run function wraps the fetch call in a try block. If the API returns an error status, we catch HTTP error, print a clear message to standard error, and return exit code 1. If the request times out, we catch timeout, print a different message, and return exit code 2. Exit codes let other tools know whether the run succeeded. Notice the user always sees a friendly message, never a long traceback. That is the difference between a script and a tool. No silent crashes. The CLI module handles saving and summarizing. Save_JSON writes the response to a JSON file inside the data folder, named after the city. Print_summary pulls a few fields out of the dictionary and prints them in a human-friendly format. Notice how each function does one small thing. Save writes. Print reads and formats. Run, from the previous file, decides what to call. This separation makes the code easy to test, because each function can be tested in isolation. Save and summarize. The _main file is what Python-m calls. It builds an argument parser, declares a city argument as required, parses the command line, and calls run with the city name. The result is wrapped in raise system exit, which turns the return code into the program's exit code. This file is tiny on purpose. It only knows how to read arguments and hand them to the rest of the package. All the real work lives in the other modules. Tiny on purpose. Tests confirm the logic without hitting the real API. The first test checks that print_summary does not crash when fields are missing. The second is a smoke test that the function runs end-to-end with normal data. Notice we do not test fetch_weather directly, because that would call the real API and make the test slow and flaky. In a real project you would use a fixture to replace requests with a fake. For now, the smoke tests confirm the parsing and formatting logic works. No network in tests. Trace one call from start to finish. The user types the command at the terminal. The _main file parses the arguments and calls run in the CLI module. Run calls fetch_weather in the fetcher module, which reads settings from config and writes log lines through the logger. The fetcher returns a dictionary to the CLI module, which saves it as a JSON file and prints the summary. Every module talks only to the ones it needs. Nothing reaches across. That is what makes the package easy to change. One call end-to-end. Packaging turns the project into a real command. In pyproject.toml, you declare the project name, version, and dependencies. The magic is in project.scripts. That line tells the installer, when the user installs this package, create a command called weather-fetch that runs the main function in weather_fetch.double_main. After install, the user can type weather-fetch from anywhere, without UV space run, without Python-m. It behaves like a real system tool. Folder becomes command. Install the package with UV space pip space install -e space dot. The -e means editable. Changes to your source show up immediately, no reinstall needed. After install, you can run weather-fetch from anywhere on your machine. Pass -city and a name. The tool fetches the data, prints the temperature and conditions, and writes the full response into data/city.json. From a folder of files to a real command in one install step. Use it from anywhere. Hold the takeaway. The capstone brought 6 skills together into one small real tool. Modules split concerns across small files, each with one job. Errors were caught and reported with clear messages and exit codes. Logging recorded every important step. Configuration and secrets lived in the .env file, never in the source. Tests confirmed the logic without touching the network. And packaging turned a folder of files into a real command. This is the shape of every serious Python project you will ever build. 6 habits, professional shape. Step back and see the whole chapter. You started with types, variables, and operators. You learned functions and IPython. You met modules, collections, loops, conditions, files, and structured data formats. You called real APIs. You stored data in databases and protected it with hashing and encryption. And in this final stretch, you wrote tests, packaged a project, built a CLI, kept secrets safe, automated tests with CI, and now combined everything into one tool. That is a complete foundation in modern Python. The whole chapter. What comes next? You have a tool that runs on your laptop. The natural next step is to put it in the cloud, so it runs even when your laptop is closed. Or turn it into a small web service, so other people can call it. Or rewrite it to process data with pandas. Or schedule it to run automatically every day. Every one of those directions is a future phase of this curriculum. Phase A gave you the foundation. Everything you build from here rests on it. The doors are open. Thanks for building the capstone. Next we look back at the whole journey and forward to what comes. One chapter closed.